Welcome back to Advent of Code 2022. This is day 11. Hope you guys are enjoying these videos. Let's get started. Monkey in the middle. As you finally start making your way up river, you realize the pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you'll need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. Okay? You take some notes, your puzzle input, on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. For example, okay, this is a somewhat complex input. We have monkey index, 2 new lines between each monkey. Each monkey has starting items, an operation, we have to parse, a test, and if true, wow, this is complex. This will be fun. Okay. Looks like our different operations are multiply and add. Our tests are divisibility only. Our if statements are if true, if false, and then a throw to monkey index. New and old are the only variables in operation, although they can be multiple times, multiple olds. I assume new could also show up here. And starting items are indexed by a number. Okay. Each monkey has several attributes. Starting items lists your worry level for each item the monkey is currently holding in the order they will be inspected. Okay, so monkey 3 is holding 1 item with a worry level of 74. Operation shows how your worry level changes if the monkey inspects an item. An operation like new equals old times 5 means that your worry level after the monkey inspected the item is 5 times whatever your worry level was before. Test shows how the monkey uses your worry level to decide where to throw an item next. If true shows what happens with an item if the test was true. If false shows what happens when the test is false. So if the worry level is divisible by 17, throws to monkey 0, otherwise throws to monkey 1. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3. After each monkey inspects an item, but before it tests your worry level, you divide by 3 and round down to the nearest integer. So you have an item here, 74, monkey inspects it. The operation adds 3, so it becomes 77, and then you divide that by 3. So 77 divided by 3 is rounded down as 25. Then you test divisibility by 17, which would be false. So then the monkey would throw it to monkey 1. All right. The monkeys take turns inspecting throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding at one time in the order listed. Monkey 0 goes first, then monkey 1, so on till each monkey has had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. All right, so monkey 0 inspects item 79, and that is multiplied by 19. If we roll up, all right, so times 19, okay, to 1501. Monkey gets bored with item. Worried level is divided by 3 to 500. Current worry level is not divisible by 23, so item is thrown to monkey 3. And then it just does that over and over again for each item. You always divide by 3. You always do the operation, then you divide by 3. Okay, what do we have to get at the end? After round 1, the monkeys are holding the items with these worry levels. Okay, monkey 2 and 3. Oh, right, because the worry level changes. So 500. So worry level 500 is thrown to monkey 3, and then monkey 3 will do the worry. Here's that 500 from the first 1. And then it increases to 3. Then it's divided by 3, not divisible by 17, throw into monkey 1. And then that becomes 167. And at the end, 167 is being held by monkey 1. After round 2, round 3, round 4, etc., etc. After round 20. All right. Chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys. If you want any hope of getting your stuff back, count the total number of times each monkey inspects items over 20 rounds. So 0 and 3, and so you got to count how many items each inspects. In this example, the 2 most active monkeys inspected 101, 105. The level of monkey business in this situation can be found by multiplying these together. So 101 times 105. All right. Figure out which monkeys to chase by counting over 20 rounds. What is the level of monkey business? Okay. So we don't have to track like individual item like uniqueness. We just have to track worry levels on each monkey and then go through each steps. So as always, we're going to start with types, then we're going to move to input, then we're going to create some helper functions to actually execute each inspection in each round, and then we're just going to run everything and make sure we're counting total inspections and multiply the top 2 together. So let's get all our inputs. Here's our example input. And our puzzle input. And day 11 and back. All right. Now let's start with parsing with some types, right? So we have a monkey type. Data class monkey. There's an index, but that index will just be in a monkey array, so we don't really need to do it. We have items, which is a list of int. Just the current items he's holding, and each of the int stands for the worry level. Operation, we'll just call it op, and that's an operation. And yeah, what is an operation? We'll figure that out. Test. It's a test. And if true is an index, a monkey index. And if false. Nice. All right. There we go. All right. So let's define test and operation. So test is an int. Divisible. Actually, we'll do at data class test, and we'll do divisible by int, and we'll do def pass self worry int bool equals return worry modulus self dot divisible by equals 0. All right, so now we have our test. And why is this? Why does it not like it? I don't know why it didn't like it. We're not going to worry about it. My Python interpreter in this IDE isn't working at the moment. Okay, so, and then we have our operation we've got to define. We're going to use another data class. And this is going to be, so we're going to have to create a function. So, but in reality, we are, everything is going to be something times or plus something else. So we're going to have left is a union of an int literal or old, where old equals old. All right. And then right is a union of int or old. And the middle is a union, is a operation type. And that's an enum, which we'll import enum and class operation type enum.enum, and we have plus equals plus times multiply equals star. We'll call this add. Nice. Okay. And then we have def execute or calculate mu, and then self and old is an int. We're going to return another int. We'll just do this operation. Left equals old if self dot left equals old, else self dot left. We'll do the same thing for right. And then we'll do return. And then we'll if self dot op. And then we'll do return left times right if self dot op type equals operation type dot multiply. This is apply, not pull. And we're just gonna break this up into multiple lines. Else left plus right. And you know, is this perfect? Oh, geez. No, but it should get the job done. We only have to handle two cases. Ideally, you'd put the, you know, def calculate self left right. You know, this is how it should be written. So well, now that I've started it, we'll just do it, and we'll do if self equals operation type dot add return left plus right, elif self equals operation type dot multiply return left times right. Not too bad. And then in this case, we'll just do self dot op type dot calculate left right. Nice. Oh, geez. All right, can't type. All right, there we go. So now we have an operation with calculate new. All right, so we've been writing a bunch. Passes. All right, we'll do passes. Oh, and this doesn't have a type, it goes to int. Nice. Okay, so let's do our monkey. So let's do our parse function, def init self, and then this is a block of text, so raw str. Okay, so then let's do lines. So we're gonna do monkey starting operation test if true if false equals raw.split lines, raw.trim.split lines. So what is this going to do? It's going to split each of these lines. Since each of these lines is exactly 6 lines, we can just break each line up and then, you know, set our index. Yeah, we can set the index. Why not? So self.index equals monkey.split space, or actually we can split on regex. No, you can't split on regex. It's a different function. A split space 1.split colon 0 and cast to int. Dot. And then what do we want to set? We want to set items equals starting dot split on colon space, and we're going to do int worry for worry in one starting dot split colon space 1 dot split on comma space, and that'll give us each starting item. Self dot op equals, we're just gonna do operation of operation dot split on space equals space 1. So this is gonna get us old times 19, and we're gonna pass that into an init function here that we'll write in a second. Self dot test equals, we can just do this one directly. All we need is the divisible by, but we'll just call test on you know what, we'll just split this on the colon space for both of these. Test dot split on colon space 1. So both operation and test are going to get their respective lines, and then if true, all we have to do is do self dot if true equals, and that's just an int, so we just get the last int from the line, so we just do if true dot split on space -1 and cast an int. Nice. All right, so that's good. So we just got to write init functions here. So def, not operation type, so that's already got one. Def init self, and then we have line string. All right, and so first we're gonna do left right equals line dot split on equals EQ left and EQ right, and we're gonna assert EQ left is new. Then we do left right equals EQ right dot split on space left middle right, right? And then we do, okay, so if left is equal to old, or old, capital old, left equals old, else self.left equals int of left. And we're gonna do the same thing for right. I don't even know if these types will work, just like using a string as a type, but we'll see. Some type systems will handle that, like TypeScript definitely handles it. And then actually the middle is really easy, self.middle or op type equals operation type middle. Because the wonderful thing about enums is you get initializers from the value. So that'll be nice. So that initializer works. And then all we need to do, whoa. Just gonna throw that down here. And we're gonna do def init self line stir, and this we're just gonna do self.divisible by equals int of line.split on space -1. Nice. Okay, so that should be all of our inputs. So our input is gonna be monkeys. It's a list of monkey, and cool, nice, and parse raw. We just need monkeys, and we're gonna do dot split on double new line, and we just do monkey block for block in. There we go. All right, so now we've parsed the inputs. Let's print the inputs. Print input.monkeys for monkey in monkeys, input.monkeys, and we're gonna do a string function, def string self. Let's not write a string function, that's wasting time. Python day 11 example. Trim is not a function, right? Of course it is strip. All right, we have monkey 0, index 79, 98, an operation from old multiply 19. Test is divisible by 23. True, if true to 2, if false to 3. Cool, so that is ready to go. All right, so what do we want to do? For part 1, we want to keep a list of every time we inspect a monkey. So inspections equals I to 0 for I in range input dot len of input dot monkeys. Actually, we'll just do input dot monkeys. All right, so the inspections are per monkey, so we're going to track them by index. And we're going to do monkeys, input.monkeys. All right. All right, and then, so def throw. We're going to take a worry level. And to index is an int, and we're going to do monkeys to index dot items plus equals the worry level of the item. So we're just going to throw an item to a worry level. That's a nice helper function. We're doing this inside part 1 so we can leverage our monkeys list here, which is going to be our modifiable, mutable monkeys, as it were. So def inspect. So when a monkey inspects an item, this is going to be our function to actually execute it. So we're going to take a monkey and we're going to inspect an item. This is the process for inspection. So we're going to have item equals monkey, and they start with the first item, right? They start with 79. Yeah, we start with 79. So we're going to pop off the top. I forget pop. Python 1, 2, 3 x equals. So I'm just x.pop. What does it do? It gives us 3. So we really don't want that. We want the head. So we're going to write our own function. So item equals monkey 0, monkey dot item 0. But we'll just write a little pop function. Def pop item self item equals self dot items 0 self dot items 1 by self dot items. Do a little assignment trick here. So we get the first item off, and we reassign the item to the rest of the list. Return item. So it's mutable, but you know, it's fine for now. So then this item equals monkey dot pop item. Oh, and then we should do inspections monkey dot index plus equals 1. All right, and then we have the item and we do the operation. So worry equals monkey dot operation op dot calculate, and we pass item in, and that gives us our worry. So we'll just call this worry 1, worry 2, and then worry 3 equals worry 2 divided by 3. And we'll just round that down using the in function, and then pass, test equals monkey dot test dot passes worry 3, and we'll just do an if here. If it passes, then throw worry3 to monkey.ifTrue, else throw to if false. And then, cool, and then we just need to inspect. So now let's just do a whole round. How many rounds do we do? 4 round in range 20. We'll go 1 to 21 here. So we get actual round numbers. Then for monkey in monkeys, we want to inspect all their things. We'll do inspect all monkey. So that's a new function we need to make. We don't need to make a function. We'll just do while monkey.items greater than 0, inspect monkey. And then that should be good to go. That should do it. And then that should run through all 20 rounds and inspect everything until there's nothing to inspect. And then we will return inspections.values, vals, I believe, sorted as a list, and then take the top 2, -2 to the end, xy, return x times y. All right, so that should multiply the top 2 values in that of the inspection counts. And yeah, I mean, we could just try it. I mean, you could also just, with something so complicated, you probably want to print and make sure you're matching all this stuff. Let's just see if we get it right. I mean, what's the harm? Operation has no attribute calculate. What did I call it? I said calculate new. Let's just call it calculate. Item is not defined. Opt to calculate item. I called it worry1. Dict has no attribute values. 10605. That is correct. Cool. All right, let's try it on the input before we start debugging. See if we're wrong. We were right. Cool. So that's really awesome that we were able to take that huge word problem into complex parsing and just write it correctly the first time. You're worried you might not ever get your items back. So worried, in fact, that your relief is that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. These new rules still figure out the monkey business after 10,000 rounds. Okay. So it's going to get to big ints, but the cool thing about Python is big ints are just ints. We don't have to worry about it. So I'm just going to copy everything from part 1 into part 2 since it's very similar. And we just don't want to divide by 3 here. So we're just going to do worry2 and there. And then we do 10,000. 1 0 0 0 0 1. Okay, 1 to 10,001. And let's see how long this takes to run. It's taking a long time to run. Pip install tqdm. tqdm is a nice little package. Import tqdm. This little guy will help us figure out how long this is going to take very quickly. So we just do tqdm.tqdm here and go. Oh. Oh, it's stuck on 536. It was moving quickly. Wait. Why is it stuck on 536? It's going to take a while to execute. Why are these? I guess my question is, why are these rounds taking longer? That doesn't make sense to me. These rounds shouldn't increase in time to calculate. So I'm going to do sum of len of monkey.items for monkey and monkeys. What is the, we're not increasing the number of items. There's always 10 items. So why is it suddenly going slower? Why would each round get slower? For monkey and monkeys, inspect. Where you just calculate and throw. Inspections begin equals sum of inspections.values. And then inspections end, print inspections. Round, inspections, end minus inspections. Begin. This is what I don't understand why this is slowing down. Is it a Python thing? Are we keeping something in memory too much? Too much popping in and out of... Yeah, like why is round 855 taking forever? Every time we inspect a low number, it's taking a while. Monkey 2, inspection 150 something. Monkey 2 is... Monkey 2 has the times old. Okay, so 150 squared is creating a big number. Is that why it's... And then our test of divisibility is taking a while. Python time function. We're going to import time to do some timings. If we can fix this problem of it taking a long time and get off the ground. In the meantime, I suppose we should, how are we going to make this faster? All right, so monkey 2 inspection 140. All right. Takes a quarter second. That is our problem, right? If everything took 1 millisecond or less, it wouldn't be fine, but 250 milliseconds every time here. Let's just go in here from day 11, import star. All right, so now we have everything in here. So we're gonna do, all right, so we have to input equals parse input with open example as f. Input equals parse input f.read strip. Okay, and then monkeys equals input.monkeys. Nice. All right, so then we just want to test monkey 2. m2 equals monkeys 2. m2.op.calculate 150. That seems to be really fast. m2.test.pass is 22500. False. m2.if false. Yeah, I don't understand what's taking too long. All right, so we're just gonna do this after each line. So we're just gonna start printing these after each line. Worry 1, worry 2, worry 3, test pass, and test fail. All right, so worry 1, very imperceptible. Worry 2 is where it takes a while. So over half a second just to do op.calculate. So maybe we can make this faster. Left equals old if stuff to left equals old, stuff to right equals old. Op type.calculate. this hack make it any faster? You know what, maybe we need to cache. From functools import cache. Let's see how this goes. All right, so we're gonna remove all our print statements. Please print. Don't want to remove those two. Unhashable type operation. Because it has a caching function. Python functool Python cache method. Or method. Cache property. The cached property is a property. We need a method. Oh, right. Yeah, you can't take. Okay, so we're just going to do def calculate left union int old right union int old op type operation type. We're going to do cache on this, and we're just gonna do this and do, so yeah, we're moving self.write old, moving this to a regular function and some naming. So we'll just do x left, x right, and x left, x right, and remove these selfs. Okay, so now this caches. Maybe it's faster. Old is not defined. Old is not defined. Oh, right, and old int. We actually have to pass the old int, right? Self.op type. Self is not defined. Okay, this one still very slow. It's moving, but just like, why is squaring these numbers so time consuming? Don't get it. Well, it's gonna run. I'm gonna kick off another one. John Advent 2022, day 11. Sorry for the noise. And we're just gonna run on the input. Oh. I don't know why TTQDM isn't installed in. Anyway. All right, so now we're running it in both terminals here. It's much slower on the right. So while this is running, let's think about how we can speed it up. Does it ever create a circle? Or a loop? Because these things have that divisibility test, it's very difficult to now we don't have that divide by 3, right? So it's roughly 10x. So from round 1000, this is 5204, this is 5192. It's basically 10x. 5204 times 10 is 52040. So there's an extra 150 in here. So the growth is approximately linear. Yeah, I mean, we're doing 1 item a second. Is ridiculous. And items here are rounds. But the number of total inspections, right? So total inspections are 100 inspections per round, 10,000, 100,000, 150 inspections per round. So, yeah. So we're doing 150 times 10,000 in the example, and even more in the problem. So yeah, monkey 0 is going to throw to 5 or 6. Monkey 5 will throw to 4 or 6. 6 will throw to 4 or 7. So they'll end up being on 4 or 7. 4 will go to 3 or 7. So they'll end up being on 3 or 7. And then they'll end up being on 2 or 3. So we'll end up being on 2 or 3, which will throw to 1 or 2. I wonder if we could invert it. What if we started with each item? So, okay, we start with this 72, and we just calculate everything that happens to this 72. It gets multiplied by 13. Right, we're just gonna go over here. So 72 times 13, and then we do 936 divided by modulus 19, 5, so it's not 0. So that's false, so it gets thrown to monkey 6. So then, instead of just moving to 97, we just go to monkey 6 and we say, okay, monkey 6, you now take care of 936. So you do 936 plus 8. And then you test divisibility of 5, which it's not. 944 is not. You throw to monkey 7. So now we have monkey 7. We do 944 times 7. Then we test divisibility by 3. which it's not. It's 2. So 6608 now gets thrown to monkey 3. So we've calculated 3 inspections for that number. And then the next round, it's in monkey 3's bucket. And because there's no dividing by 3, it just will constantly keep growing, right? Nothing's going to subtract it. So each number will grow at some rate. So maybe we can use a modulus to keep these numbers from getting so large. We could use the greatest common denominator of all of these divisibility checks are primes, right? Yeah, they're all primes. So we could just GCD everything to keep our numbers smaller. Okay, all right. Because then, if we modulus by the GCD of all these primes, divisibility by all those primes will not be thrown off. Okay, all right. So let's do our GCD equals monkey equals reduce lambda a times b in monkeys, and we'll do monkey dot, one of these squares, but yeah, it's okay. So time dot test dot divisible by for monkey in monkeys 1. Okay, so what this will give us is the greatest common denominator of all these divisibility tests. So when we throw, we're going to do GCD. We know that some of these op calculations take a while for big numbers. And this will keep our numbers in the integer range. So we're going to cut everything off because it's not helping to just, oh shoot, I just closed all my terminals. Dev John Advent 2022, day 11. Python day 11, example. Of course, Python 3, right. Reduce is not defined. They move reduce into a functools in Python 3. Okay, that made all the difference. We modulusing by the GCD made all the operations run much faster because they're not going into big ends. And we get a number that's close but not correct. Okay, well, at least we're getting somewhere. All right, so let's go down and let's debug this system. All right, the GCD. How can we test the GCD works? Let's move it back to part 1 and implement it in this throw function and see if we get the same example. Okay, so it doesn't affect the answer in part 1, but remember part 1 had the divisible by 3 thing, so it wouldn't be getting as big a numbers. So let's print our inspections after each round. So and we're just gonna remove all these debug statements. If round equal in 120 or round mod 1000 equals 0, print round print inspections. Is that going to be true? Round 1, 20, the beginning, and these are after, so we want to do at the end here. So we just do this. Okay. All right. So after round 1, we have 0, 5, 1, 5, 2, 0. But that's not correct. And I'm going to remove the TQDM here to clean up our output. Okay. What do we got? All right, GCD is 96577 because it's the multiple of these 4 numbers. 23 times 19 times 17 times 13. Okay, right? So any number modulus the GCD will not affect the modulus of any of the subnumbers. So 88888 mod 23 is 22, and mod this mod 23 will still be 22. That is the point. And so it keeps our numbers reasonable. So after round 1, I don't understand why 0 is going 5 times. Let's remove the GCD modulus and see if we get this correct. No, it's still doing 5 times. All right, so we're just printing it wrong. This says after round 1, monkey 0 inspected items 2 times. And that does make sense. Inspections. Everything starts at 0. Why would we call inspect on monkey 0 multiple times? This shouldn't affect anything. Still doesn't affect anything. Okay, all right. We just want to run the first round. So I'm going to go break here. So we just do the first round. So on round 1, print inspect monkey.index monkey.items. Monkey 0 is inspecting, has 5 items in the list. Why does monkey 0 have 5 items in their list? The example only has 2 items in the first monkey's list. Yeah. 79 and 98. What is going on? Oh gosh, this is guys, this is why I don't program mutably most of the time. Here's a big lesson. Our bug is being caused by running part 1 and then part 2 on the same monkeys. So they're all getting changed for part 2. Oh gosh, that is frustrating. So what we want to do, we could not run part 1, but I don't like that. I'm going to do a copy on the monkey, and so return monkey index equals self.index items equals item for item in self.items. You know, oh geez, I moved it to the wrong screen. There we go. All right, so making sure to copy the list here. All right, op equals self.op because that doesn't change. Test equals self.test. If true equals self.if true, keeping no space. If false equals self.if false. Nice, and then monkeys equals m.copy for m in input.monkeys. Copy that list over here. Whoops. There we go. All right, let's run it on the example. Monkey is not defined. Yeah, so we can just do a type hint here. Function has no attribute test. We need to call copy. Monkey.init got unexpected keyword argument index. But it's a data class. It has key index. I just want to get this working. Well, but it's a data class. Oh, right. Of course, because we have this init function. Right, of course. All right, what are we going to do? All right, we'll copy it beforehand. So we'll just do... We'll remove these copies. And we'll copy it in our calling function. Normally, I just don't like to program mutably, and this is why, because now I'm trying to figure out. So what we're gonna do is just have two inputs, input 1 and input 2. These are gonna be different objects, and now we can solve the problem. Example. Cool. All right. And we got 0, 2, 4, 2, 3, 6. Nice. Okay. We can remove this debug statement and remove this debug statement. Go. 27133. Is that correct? That is correct. We will now remove these debug statements and run it on the input. And give our answer. And that's correct. All right. So what was the key to this problem? The greatest common denominator. That's what you had to see in order to calculate it quickly. When we just implemented part 2, we saw that it was too slow, and we tried to figure out how to speed it up. We noticed that the big things that were taking a long time were squaring these numbers so that they became really, really big numbers. And without the divisible by 3 rule, everything was becoming huge numbers, which caused every single modulus operation to take a long time. When you keep things to regular integer or long integer size and not big int, everything's very fast. But when it got to really, really big integers, it got very slow. So we had to notice that the only checks we were doing were on divisibility, and each divisibility was being done by a prime. Therefore, the greatest common denominator is just the multiple of those prime numbers. And we didn't have to implement a GCD function. So that was really, really cool. We got thrown off with a bug by having mutability, right? Every time we moved items around with this throw function, we were mutating the list, and that really messed us up for part 2 because we're mutating the same monkeys. If I was doing this over again, I'd put the items list inside the part function and not inside the monkeys. The monkeys would have their starting items list, but it wouldn't be the items that we actually throw around. And instead, this items list would be some items list inside this function. And that way, we're mutating things inside the function and not outside the function. So yeah, one bug, didn't need to introduce that, but we did figure out the key trick in order to make this fast. So pretty proud of that solution. Hope you guys enjoyed it and the process of me figuring it out. I certainly enjoyed figuring it out myself. But I'll see you guys tomorrow.